Okay.
Okay.
Any more questions?
I have one question that was like from the previous lecture.
Yeah.
Um, so so if we solve the time dependent sorting, I can't say that word. The equation, the Schrodinger
Sure.
equation. Yeah, yeah. So the solution we get is like the unitary operator, right?
Yeah.
Like, is there a formal way of producing the answer, or is it just something we know?
Oh, yeah, yeah. There's a formal way. I mean, you just um, yeah. I mean, so this is your equation, right? Uh, I h bar uh, d by dt psi of t, and then h is the important thing here is that h is time independent. So I can write this as this d times psi of t and h psi of t of dt, right? And because this is time independent, I can write it as IH. Now I can just integrate it, and on the right hand side, well, you know, of course, what we're doing here is quote unquote dividing by uh, by it's yeah. So what is the formal solution of this equation? It's I times log of psi of t, and then I have h acting on some uh, mm, okay, yeah. So I think the better way to do this is like this. The better way to do this is assume that an operator u which acting on psi of 0 gives you psi of t. Oh, by the way, if somebody has to leave, please. I mean, I know who were here, so I will just give you your attendance. You don't have to stay around. So you use this in this equation, right?
Mhm.
And then what you get is you get I of h and then d of u of t by d of t. The idea is to turn this into an operator equation, okay? And then you have h of u of psi of 0. And this is t. And then what you do is that you get u of h, then del of u of t of del of t, and then you get h of u. This is your, because you're going to be assuming that it's valid for all states, right?
Mhm.
And psi of 0 is some arbitrary state. So this is the operator equation. You can think of it as a matrix equation if you like, and then you can say, okay, I can write this as I can write this as I h bar d of u of t times u inverse, and then I have here h of d of t. Okay, so now you can write this as minus of, say, yeah, and then you integrate this equation. And if you integrate this equation, you get log of u of t, and here you get h minus I by h bar of t, plus, some, some constant, and you say that at t equals to 0, your boundary condition should be that the unitary transformation should be 1. Okay, so that produces log of u of 0. Sorry, that that is going to be 0. Okay, and then if you take the antilog of this guy, then you get u of t is e to the power minus I h by h bar of t. Okay.